When you hear the word slope, you might think of a ski slope or snowboarding or something like that. But in terms of math, when we think of slope, we're talking about what's happening to a line as we go from left to right, meaning how much is it going up or going down as we move from left to right. So for example, if you look at this blue line here, this is a graph of a linear equation, and we can see as we read from left to right that the line's going up. Again, this is our x-axis and this is our y-axis. And our blue line here represents the solutions to a linear equation, and it's increasing as we move from left to right. Slope tells us how much it's increasing or decreasing. So if we look here, if we pick 2 points, that lie in the grid lines of this line, so perhaps right here, the point 1, 1, and the point 3, 4, we can figure out how much it's increasing from left to right by saying how much it rises over how much it runs. Now you've probably heard of this phrase before, rise over run. We can use rise over run to figure out the slope of a line. So from here, if we rise 1, 2, 3, and we run 2, the slope of this line is 3 over 2. Now the cool thing about this is that works for any points we pick on this line. Let me give you an example. Let's say we change our mind about these points here. If I can get them to erase. There we go. And let's say I wanted to pick from this point here, the point -1, -2. And let's say I wanted to go up to this point here, the point 5, 7. Okay? If we're going to talk about rising, from here we go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to run, go over 1, 2, 3, 4, 5, 6. So we rise 9, go over 6. Now look what happens to 9 over 6. Rise over run. 3 goes into 9 3 times. 3 goes into 6 2 times. We get the same slope. So what slope tells us is how much something is changing as we move from left to right. This one means for every point I go up 3 and over 2. Now we could do this every time, this rise over run, or we have what's called our slope formula. And so I know you might need to pause the video to write this down. But basically our slope formula says the difference in our y's, we call it y sub 2 minus y sub 1. So we're taking how much our y's are changing over how much our x's are changing. X sub 2 minus x sub 1. And we use the variable m to represent slope. So this is called the slope formula, and what's cool about this is we are able to find slopes of lines without having to graph it. If you look here, if we're given a line, we can find the slope using rise over run. But what if you don't have the graph and you just have some points? If we just have some points, we can figure out the slope using our slope formula. Again, if you look kind of in this one here, and they do it a little opposite, we want to take how much our y's are changing, that's this right here, rise, over how much our x's are changing, that's our run. So this really is still rise over run, it's just specific to 2 points. Let's look at an example. It says find the slope of a line passing through -3, 0 and -1, 6. Again, our slope formula says the difference in our y's, y sub 2 minus y sub 1. And this is really important, guys, y's go on top, because remember we're talking about rise over run, rise, the change in our vertical numbers. So y sub 2 minus y sub 1 minus x sub 2 over x sub 1. And it doesn't matter which ones you label as point 1 and point 2. This represents point 2, this represents point 1. So if we go, call this x sub 1, y sub 1, because this is the first point, x sub 2, y sub 2. Let's watch what happens. Our y sub 2 is right here, it's 6, minus our y sub 1, which is 0, over x2, which is a -1, minus, be very careful here, we're always subtracting whatever x sub 1 is, and it's a -3. Simplifying this, 6 minus 0 is 6. Minus a negative, remember when you see minus a negative, go keep, change, change. So keep, change, change. Negative 1 plus 3 is 2. And then 6 divided by 2 is 3. Now the way you can think of this, if you think of it in terms of rise over run, is you're rising 3 and running 1. Now we don't really need that 1 on the bottom, but we know we can always put it there. So our slope is 3. Now remember what I told you, it doesn't matter which point is which. So if we change this to x sub 2 and y sub 2, and this to x sub 1 and y sub 1, using the same formula, our y sub 2 is now 0. Our y sub 1 is 6. So 0 minus 6 over x2, which is a negative 3, minus our x1, which is a negative 1. Zero minus 6 is a negative 6 over, keep, change, change, negative 3 plus 1 is a negative 2. Negative 6 divided by negative 2 is a positive 3, which is what we got before. So it doesn't matter which point you pick to be point 1 and point 2, just as long as you keep this all as point 2 and this all as point 1, or vice versa. Let's look real quick at another example. Okay, we're going to use the same formula right here. Okay, so label your points. I find it easiest just to label my points first. And plug them into our formula. Our y2 is a negative 3 minus, I always write the minus right away, and then I go back and find our y1, which is a negative 3. And then we have our x2, which is 5, minus our x1, which is a negative 1. Now watch what happens in this problem. Again, minus negative, so let's go keep, change, change, keep, change, change. Negative 3 plus 3 is 0 over 5 plus 1, which is 6. In this case, it really doesn't matter. 0 divided by anything is going to be 0. So our slope of our line is 0. So what does that mean? What that means is we move from left to right, we're not going up or down at all. So this is actually representing the slope of a horizontal line. And we'll talk more about that later. A couple more examples real quick. Again, if I write down my formula, slope equals the difference in our y's over the difference in our x's, rise over run. Okay, and if we're going to label our points here, this is x1, x2, or you can again, I'm sorry, x1, y1, x2, y2. So our y2 is negative 3 minus our y1, which is 1, over x2, which is 1, minus our x1, which is a negative 2. Okay, again, be careful with negatives. Negative 3 minus 1, or keep, change, change, negative 3 plus a negative 1 is a negative 4, over, keep, change, change, 1 plus 2 is 3. So notice in this case our slope is just a negative 4/3. Leave it as a negative 4/3. Leave it as an improper fraction. Don't make it into a mixed number. Don't change it into a decimal. Because what this is telling us is that on our line we're rising negative 4. Well, we're going down negative 4 and we're moving over 3. So it's telling us what our line looks like. Leave it as a negative 4/3. The last one to talk about real quick, again using this formula here. I just want to make sure you see this example of points. So it says find the slope of the line passing through 0, negative 1 and 0, 4. Okay, again, we can find the slope of this line without having to graph it. Our y2 is 4 minus our y1, which is a negative 1, over our x2, which is 0, minus our x1, which is 0. Now in this case, keep, change, change, we get something called 5 divided by 0. Is it possible to divide by 0? No. This, when we see a solution, when we see a slope that has 0 on the bottom, we call it undefined. Okay, undefined. And that's important to remember. Whenever you have 0 on the bottom of a slope, a fraction, a ratio, however, we say it's undefined. Now think about what this means. On our graph, we're rising 5, and then 0 tells us we're not moving left or right at all. So in this case, this is actually what would happen if you had a vertical line. And we'll spend more time talking about horizontal and vertical lines in the future. But whenever you have a 0 on the bottom, we say it's undefined, because slope tells us what's happening as we move from left to right, and a vertical line doesn't go left or right at all. Okay? Again, the key point to this lesson here is knowing your slope formula.